There we go. Okay, now it started. Okay, I thought I was going to have to restart my computer, but I wished one of the things I would have done was put this up here first, then hand those papers out. So, and again, on your paper on the top, it's going to say chapter 10. That's really where we're at, but it's going to say section 9.1 or something to that effect. It's the same material, but it's from a different edition, okay? But it's the same author, so really it is chapter 10. But as you look at this, what's some of the first things that comes to your mind when you see this right here? Okay. You're doing it right now, you just don't realize you're doing it. What's that? You're thinking. That's right. What else? Okay, so when we say that we're thinking, okay, that can mean one of two things. Either one, you're trying to remember something, or two, you're trying to possibly, I don't want to say being analytic, but maybe abstract, for instance. Perhaps just different ways of looking at something, trying to figure that out. An example of that would be, if you can picture things in your mind, this would be types of like abstract thought where you're doing these electron dot diagrams, which, yes, I'll have that on the Science Channel for some of you for later. And then, like I said, this is abstract thought, or Bing Bong is abstract thought. Don't let me down. Who is Bing Bong? You're letting me down. Inside Out. Yes, the elephant from Inside Out. And what is that character? Just don't say an elephant, but who was Bing Bong on Inside Out? An imaginary friend. And I never had one, but I don't know, maybe you're shaking your head no. And even if you did, I don't know if someone would admit to that. But I suppose for me, just being raised on the farm, I could probably say I could have lots of imaginary friends. Dogs, cats, go shoot the breeze with the bovine maybe, or saying, "Why do you eat so much, you pig?" That was funny. Why do you eat so much, you pig? Who am I talking to? A pig! Well, no, not you. Anyway, so all those are examples of whether, in this case, it was an imaginary friend. And a lot of the things that happen with this deals with our emotions too, okay? Not that I'm a Green Bay fan, but in a family group pick 'em that you can do through ESPN, like I said, I'm not a Green Bay fan, but I picked them to win. And if you know what happened, Green Bay won on a last-second field goal, and it's just like, yeah, I got another point. So your emotions deal with, how well things may or may not be going. I was talking with some of the volleyball ladies last hour. Your feeling of how this weekend went. You went 3-1. Are you okay with that? Okay. Sometimes you get a win and you don't feel good about it. So, and I think that's a logical approach, that when you're looking at something, whether it's Allstate, because some of you are going to do some of them auditions. I think they're coming up here pretty soon.
Oh, you already have them.
Okay. And one of the things that, whether it's the fine arts or whether it's athletics, the last thing you want to do is, I wished I would have practiced more. I don't know if you tell yourself that or not. And one of the things that I've noticed students saying as far as doing these all-state editions, I think, is sometimes you have judges just walk and they'll ask you to read. You need to memorize something. I can't remember what it's a special procedure. I can't remember what that's called. I'd have to ask Mrs. Olson. I mean, my memory's just eluding to me right now. But again, whether it's band, chorus, volleyball, cross country, basketball, sometimes I think a good way to approach that is there's always room for improvement. Okay, so what does the brain do for us? Okay, the peripheral nervous system, okay, anything that branches off, okay, and then your central computer. What is your central computer? Your brain and in the middle of your back. Your spinal cord, yep. So we're dealt with the feeling, or your emotions, your thinking, your memory, your sense of awareness. You might think, well, why would we be dealing with something like that when we're talking about a sense of awareness? Well, as we get older, okay, it's a long ways off for you people, and hopefully it's a long ways off for myself as well, and that is for some of your parents, if they're maybe on Facebook, sometimes you might see emergency services putting out a public address announcement that please be on the lookout for this individual because they wandered off from their care unit or something to that effect, okay? And just their sense of awareness, maybe they don't want to be in that nursing home or assisted living. And I think that's something that we're all going to have to bear at some point. I mean, like I said, for you people, that should be at most 60 years away from now. Or at least, I mean, not at most. And maybe for myself, maybe you find me in the loony bin 5 or 10 years from now. Nah, hopefully not. But anyway, these are your major functions, what your central nervous system and peripheral nervous system is going to do for you. Your central computer has so many things to control, but it does it so quietly, okay? Because one of the things that we think about is just the number of transmissions it sends out, whether it's dealing with respiration, digestion, circulation, damage control, for instance. Maybe it's got to tell your pancreas, your liver to work together. So there are so many things that are going on that actually keeps us out of harm's way. Okay. The basic unit of the nervous system, as you can see, is right here, just the neuron. Okay? Now, the reason we say the basic unit, because there are different types. There's Schwann cells, there's astrocytes, there's oligodendrocytes, there's microglial cells, there's glial cells. All of them are just components that we call neurons that are going to make more specialized tissues that are part of this nervous system. And for instance, today, okay, a physical change, okay, that could take place outside, not just the meet that we're going to. What might be a physical change that runners are going throughout the course of the day or the meet? What's probably going to change for yourself physically, do you think, as you run further in your race?
More tired?
True. But that would be more so over here probably. But in your case, what is it that you do at the beginning of the race when the temperatures are like this?
Yeah, no water.
Yeah, you dump water over yourself because your body temperature is going to start to do what? Body temperature is going up. There's just a set range that our body works most efficient at, and that range is probably from about 93 degrees. That's really low, but it can function, all the way up to, and during the course of a competition like that, to me, it's no stretch of the imagination. Your body temperature gets up to probably 101 degrees, 102 degrees. When you think, oh my God, we're running a fever. Well, no, you just actually ran a race on a hot day, but your body compensates for that by causing you to sweat. Your body temperature is going to come down slowly, but your core body temperature, that could very well be up to 106 degrees. Now, yes, that is bad. There's no doubt about that. But again, your body will develop changes to combat that. And one of them is not just the sweating that would take place with this, but what do you notice about your blood vessels when you get warmer or hotter? What do they maybe do at your skin's surface? They get bigger or smaller? You got a 50-50 chance. If you have lots of heat in your core and you send that blood towards the outside to the surface of the skin, the more blood that you can send to the surface of your skin, the more heat you can radiate to the exterior. So that means your blood vessels are really going to get big. They're really going to dilate. That way you're sending more of that blood from your core to the outside so that heat can then be dissipated. Now, of course, just the opposite can take place when some of us are looking at December, January, and February. How many of you are winter month people? I think you're in the minority, which is fine. People have their own opinions, just as long as Santa knows where you live. Does Santa know where you live? Oh, okay. Oh, okay. But, doesn't he have like tattoos, naughty on one side, nice on the other? So, hopefully, maybe that happens once we turn 12 years old. Maybe we don't get put on them lists anymore, or maybe it's just a permanent nice list. Yeah, I don't know either. Only you can answer that. Okay, so physical changes, that could be your body temperature going up or down. So what could possibly a chemical change possibly be? And what happened last chapter? Chemically now. There are different examples that we could give. Yeah, digestion is a good example. A little more specific is one of the things that we had talked about as far as breaking down proteins. A signal had to be sent from the brain down to the stomach to cause what to happen? Two things had to be released.
Cells had to release pepsin.
That's one. What about the parietal cells?
Hydrochloric acid.
Yes. Okay. So that's going to be a stimulus to a chemical change, because one of the things we talked about, the acid will activate the pepsinogen to pepsin, and then that is a result of a type of chemical change that's occurring. Okay. So some of them are physical, like temperature change. Some of them are chemical, like that of digestion. Okay. Okay, so I want to talk about this slide, and then I suppose axons is next. And then once we get to the axons, I think we zoom tight. Is that a cough or a sneeze?
Sneeze.
Okay, then I was right. Okay, and then you'll have to bear with me with some of the drawings that I try to do. So if we have information that receives electrical messages, if you have something to receive that, you'd have to have something that would send it then as well. Okay? So when we look at these nerve impulses, that just means, is it going from point A to point B, or is it going from that point B back to point A? So some of these, it can be sent from one direction to another. Okay? So if you have structures that receive information, you'd also have to have those that send that electrical information then, and that's where we're going to stop the axons. Okay? What's the best way, just looking at the definition, what is the best way to keep them two separate? Your axons and your dendrites. Think about that as you're writing, especially this definition. So if we were talking about what is the name of a structure on a neuron that sends information away from the neuron, how would you know that's either an axon or a dendrite? It is, okay? So that logic, what was that? You're right. Yeah, but yeah. So you probably looked at that, right? Because you said away. Okay? So if you put that A with that one, okay, then that's how you can keep them separate. Just like parietal cells and chief cells, you can keep them separate because there is no A in chief. So since there's no A in chief, it doesn't produce acid, it produces your pepsinogen instead. Okay, I just want to, again, bear with me. We'll try to make this somewhat make sense, but my drawings, as you would guess, aren't the best. Okay? Does everyone have this information that wants it? Okay. Okay. So with this, what we're talking about here, and there's really no accepted shape, I don't think you could say for what a neuron would look like, but this is just what I usually do. Okay. Now, you're going to notice I'm putting these, I can make these longer, I wouldn't have to draw as many. These semicircles, if you want to call it that, putting them on here, there's a specific reason that I'm doing that. Okay, and then down here. Okay, so let's say a signal gets picked up here, and this is an axon, so it's sending it away. Then it's received here, continues on. Okay, then this one's going to send that information down here, and then sends it to this neuron. Okay? Categorically speaking, this is how we can tell the difference between an axon and a dendrite, because that signal is being sent away from it. But the axons and dendrites do have to come in contact with one another, because otherwise, if this axon kept on going and kept on going, the axon itself does not actually attach to another nerve cell. It has to attach to a terminal end of the axon to a dendrite. Okay? And then lastly, what I want to talk about is these structures right here. Okay? This is called myelin on here. We haven't talked about that yet. Okay? But what that does, for instance, is when you look at any type of wiring, whether it's on this microphone wiring, on this computer wire for the signal between the camera and the computer, what is it that you just don't have bare copper wiring that you see, even in computer processors? You just don't see bare wires going through in there. Why is that? What's this, you could say, colored black material on here? What does it do for that copper wiring? It protects it and makes it more, since it's protecting it, it's going to make it more of an efficient, let's say, signal. What does it mean if something shorts out electronically in a cord? What do you think that possibly means? Probably the most common diagnosis that you could say with, whether it's an extension cord or a cord like this, it's shorting out, so the signal's not getting through. What might be the reason for that?
Could be exposed wiring.
Yeah, because if you have this wire being exposed, that signal might not get through. Okay, so these semicircles here, called this myelin sheath, that's kind of like that protective coating that you see on electrical cords. And then if this starts to deplete, which unfortunately it can, people have that disorder where this starts to diminish in size, and then what happens is that signal sometimes gets through, sometimes it doesn't. And it's unfortunately some neurological disorders that you probably have heard of. Okay? One of them is like a really long name, ALS, if you've ever heard of that. More common name is Lou Gehrig's disease. Okay? And another one is called Parkinson's. Has anyone ever heard of Parkinson's? We've probably heard of it. Does anyone know anyone who's been diagnosed with Parkinson's? Okay? Because later in that stage of that diagnosis, a classic, well, not classic, but one of the things that you can really see is if they're coffee drinkers, maybe like myself, what happens is if this signal sometimes gets through and it doesn't, you can see they look like this. So this is what shorting out would be, trying to do something with fine motor skills like this. Makes it very difficult in later stages for them just to do simple tasks like pinning this on here, drinking coffee, drinking water, dressing yourself. That would make it very, very difficult just to do those very simple tasks that we take for granted. It is very unfortunate. But what happens again is this sheath starts to deplete, and then again, sometimes them signals get through, sometimes they don't. It's a type of short circuit. Okay, so we'll talk about, I believe, the composition of the central nervous system tomorrow. So we'll catch up to you next time.